In this video, you are going to learn how to use coroutines. And why do we need coroutines? Well, in Android, some operations or tasks take a longer time to complete. And these tasks block the user interface. And until they are completed, the user interface is not interactable with. So the user cannot interact with it, or at least with parts of the application, and which will make the user idle and will make him bored and so forth. So it's not a good process. It's not a good approach, basically. So to avoid this, Android UI system was built to only accept delays of maximum 5 seconds. So let's look at that. So I have this little application here, and once I click on this button, there will be a very long lasting task running. And let's just run it. You see the UI is frozen. I cannot click on anything. The app is frozen basically. And after 5 seconds, Android decides, hey, this is a bad application. It's not responding, let's close it. Even though you see it's done. So even though the application did finish, in the meantime, while this pop-up appears, so I can either close the app or I can wait and then go back to the app and it works, right? Otherwise, the user would just close it because he believes the app is bad and he's going to uninstall it, or she's going to uninstall it. So what is going on in this application that I've built here? So I have just this button, and once I click on it, it just runs this for loop, which runs 100,000 times. And it only adds a log entry, nothing too fancy. And once it's done, it's going to write this toast. But I'm doing that in the onCreate, and I'm doing that on the main thread, so on the user interface thread, which really is not good. And we can avoid that by using coroutines, which will basically push tasks that last longer into the background onto a different thread, so that the UI thread will not be blocked and can still run and will still run flawlessly and fluidly, so that the user can properly use it. So let's look at what coroutines are in a little presentation and see the advantages, and then build a little application around it. So let's look at coroutines and those scopes in a little more details. So to summarize the features of coroutines, first of all, they are lightweight. This means that you can run many coroutines on a single thread due to the support of suspension. Then you have fewer memory leaks. By running a coroutine in a specific scope, you ensure that they do not leak as it terminates at the end of its scope. Then you have built-in cancellation support. So the launch option returns a job which can be used to cancel the running coroutine. And it is integrated into Jetpack. So many Jetpack libraries include support for coroutines, for example, Room and the Work Manager. So basically, if you want to develop for Android within 2021 and later, this is definitely going to be the way to go. Okay, so then let's look at coroutine scopes. So there are built-in scopes you can use to launch your coroutines to finally execute this function. However, we need a coroutine scope. And coroutines follow the principle of structured concurrency, as I said, which means that new coroutines can only be launched in a specific coroutine scope. So if you create a scope and don't clear it at the end, you can run into memory leaks, and you want to avoid that. So let's look at the view model scope. It can be used to launch a coroutine in a view model class. It will automatically be cancelled once this view model is cleared. And then you have the lifecycle scope, which is used to launch coroutines in the activity or the fragment, and is cancelled automatically when they are destroyed. So when the lifecycle is destroyed, which is good because then you are not running into memory leaks. And you can as well create a custom scope, but it is important that you attach it to a job and clear it when the execution is done. To create one in your activity, you create a global job variable, you create a coroutine scope and attach a job to it, and then you execute it, and finally you cancel the job when the activity is destroyed. Okay, so this is how you could potentially do it if you were to create your custom scope. Okay, so now let's look at this. First of all, instead of running this code in here, I'm going to create a little function that I'm going to then adjust. So I have this private fun execute, I'm going to call it, and I'm going to pass a result into it, which will be of type string, and it's just going to execute my for loop. So here I just want to run the execute method, and I need to pass a string to it, which will be, for example, task here, task executed successfully. All right, and this should of course be used here, so the result should be used as the text of the toast. Okay, so once I execute it now, well, now basically the same thing would happen, only that the toast message would change slightly. So that's not really helping us. So how can we fix the problem that we have? Well, in order to fix it, we are going to use the suspend keyword here, suspend. What that will do is it will make it a coroutine function. So a suspend function. Now you see here, it's unhappy. So you cannot just execute a suspend function on the main thread, which is really the whole idea here. So now to stop the function from blocking the UI, we need to add suspend in front of the function, but also we actually need to make sure that it runs on a different thread. So the suspend function is just part of the coroutine class, and it has to invoke another suspend function. So now let's modify our function block a little bit. Therefore, I'm using the with context here, with context method, and I'm passing a dispatchers.io here. So neither of those is recognized, and that has to do with me not having the right implementation here, so the right dependencies. So we need to add this dependency, and it's the activity KTX, and in my case the version is 1.4.0 beta 01, and you could of course use a different version, but either way we need to use KTX activity here. And then we need to sync it, and once this is synced, we will find that we can now add the classes. And did I write it correctly? No, I did not. So with Alt Enter, you see now we have the two imports up here, and we can now use it. So with context is now going to run a coroutine. So now of course we need to put our code in there now, and at this point the execute up here is still not happy, but at least our code here is more or less ready. So here we use the with context method to run the task. With context is a method created to move an operation into a different thread until it completes its process, and then it is moved back into the original thread. And then we're passing dispatchers.io, which moves the task to a different thread, which is the input output thread, which is different from the UI thread. So it's running on a thread that is not blocking the user interface. And when we look at the on-click listener here, we can see that it's not happy, right? So we need to make a change here. So in order to make it run, we need to say on which scope we want to run this. And I'm going to run it on the lifecycle scope. So we can launch it here, and then in curly brackets, that's where we can execute our method. So in order for this to run, we need to import this launch as well. And you see here, coroutines launch has been added. So there are different types of existing coroutine blocks where you can launch a suspend function from, depending on the class it has been called from. So lifecycle scope is a coroutine block built to properly handle coroutines in any activity class. So now when we run the application and click on the button, after it completes, the app crashes with an error. So let's test this. So you see in the background, it created all of our entries, all of our 100,000s of entries, right? And in the end, it crashed. Okay, so coroutines stop working. So let's close the app, and I still have the other iteration of the app running. And our application crashed because of a very simple thing. We are trying to run this toast on our background thread, but the toast itself is a foreground or a UI task, okay? So our UI related action, like this toast, can only be run on the UI thread, but currently we're running it on this dispatchers.io thread, and this cannot work. So how can we fix that? Well, we can add something that we want to run on the UI thread specifically by calling the run on UI thread method here. And we can then say what kind of action we want to execute on the UI thread inside of this coroutine. So here I'm just saying run this on the UI thread, and there particularly the toast should be run on the UI thread. So let's test this again and see if our application is going to crash. And we can see it's running in the background, so stuff is happening, and our application doesn't crash while I'm starting it again and again. So I have multiple iterations of my task, and once it's done, it should display my toast here at the bottom. And we can see here, there it is. It took quite a while, but that's just because it takes a while to run the task 100,000 times. So now what we could do is, of course, limit it to 10,000 times, then it would run a lot less, or 50,000, maybe, or 20,000, something like that. Okay, so that by itself is cool, but now let's see what is a good approach if you have such a situation where you want to run something and you want the user to wait for a response. Well, what you can do is you can add a progress dialog. Okay, so I'm going to create this new dialog entry here, which will be of type dialog and dialog nullable to be precise, and will be null at the beginning. So this one will be a var custom progress dialog of type dialog. Let's import it, and now we can use it. So this will be the progress dialog, which will just be a dialog inside of this context. I'm setting the content view to be this dialog custom progress bar, which is this custom progress bar, which says please wait. Okay, so this thing will circle, and then this will say please wait. And if you look at it, it's just this progress bar with a width of 50-50 with a little bit of margin, and then we have this text view which says please wait. Okay, so then I have a way to show the progress dialog. Now let's add a way to cancel the progress dialog, because otherwise we don't have a clean way of canceling the progress dialog, and I want to be able to cancel it once we are, for example, done with our execution here. All right, so what can we do now? Well, we can say once we clicked on the button here, before we launch the lifecycle scope, let's show the progress dialog. And then once we are done and we start running something on the UI thread, we can cancel it in the UI thread. Okay, so here cancel progress dialog, which handles a progress dialog, which should be also handled in the UI thread. Okay, so progress dialogs, they show something. If you show something specifically, that has to do with the UI thread. So let's run this application again. It will be a lot more appealing. So now we can see, okay, please wait. And we know that we should wait. And once the task is done, you see task executed successfully. And you see, even if I click away, the UI still works and the task will still run in the background. It will succeed successfully, and I can run my application cleanly. So this will make sense for tasks that will take longer, for example, loading data from the internet, or like doing bigger calculations that will just take time. So that's where it really makes sense to use your coroutines. So just quickly a summary. If you want a function to run as a coroutine, you need to add the suspend keyword. You need to add the with context, and then you say on which context you want this to run. So on which thread you want this to run. There are multiple options. We're just using this dispatchers IO here. And then if you want to execute this function, you need to define on which scope you want this to run. And I want to run it on the lifecycle scope here. I launch it, and then I can execute my suspend function or my coroutine function. So that's generally the structure that you can use for your coroutines. There's of course a lot more to learn about coroutines, and I even have a YouTube video on it where I go into a lot more depth. So definitely check that one out. And yeah, see you in the next video.